Your job is to make sure I have my audio on all the time. Okay?
You have your audio on?
Yeah, I do. Thank you.
You still have your audio on?
Pardon?
You still have your audio on?
The light's red.
Okay.
For the abyssers out there that are following along, my students are trying to keep me on task. And so if you can hear me now and weren't able to hear me last period, that's because my audio wasn't on. Okay?
Audio still on?
Yes, it still is. Okay. Okay, all of these right here are implicit equations. Okay, you know they're implicit when x and y are on the same side, or another way to know is that y is not by itself, or x is not by itself. So what I'm going to do is I'm going to rewrite these so these are explicit. That means I am going to get y by itself. And you probably did this. You probably would subtract 2x and get 3y equals a negative 2x plus 6. You remember doing these, right? And then you would divide by 3 and I would get y equals a negative 2/3 x plus 2, right? I just went from implicit to explicit. And dy dx, Denise, is what? If I asked you to take the derivative of that, you would get what as your answer? What'd you say again? Negative 2/3. Awesome. So on this one, to get explicit, I would first write y squared equals 25 minus x squared. By the way, does anybody know what shape this is? It's a circle. Very good. What's the radius? 5. And that is not a function, is it? But there's a tangent line that goes right here that has a particular slope. Would you agree with that? And so to continue on, I would say y equals plus or minus the square root of 25 minus x squared. It's not a function because if I put 0 in for x, I would get a positive 5 and a negative 5 as my answers, right? This would be nice. This is simply y equals x squared plus 6. And this would be y equals 1 over x. By the way, Caitlin, what is the derivative of y equals x squared plus 6?
2x.
Very good. And Alexis, what's the derivative of 1 over x?
Negative x. Or 1 over, or negative 1 over x squared.
Very good. Did that in your head? Awesome. Allie, do you want to take the derivative of that? No, I don't either. You know why? Why don't you want to do it? It does, doesn't it? Because you got this plus or minus out there, you got the square root, looks like you got the chain rule, it looks like it's a mess, correct? I'm starting to get a headache. And if I go back to this one, what was it? X squared plus y cubed plus y equals 3. How would I take the derivative of that? Right? So, variables agree, variables disagree. Let's go back to this one. Y equals x squared. Caitlin, you did that one, right? Or was x squared plus 6, correct? I lied to you. This is dy dx. In other words, I'm taking the derivative of y with respect to x. This is 2x times, I'm going to take, x is a variable also, correct? I have two variables, one x, one y. I'm going to take the derivative of x. It's going to be 2x times dx over dx. Plus, I'm going to take the derivative of this constant 6. It's 0 because 6 never changes, does it? Over dx. Now, I don't write this, Aiden, ever. You know why I don't ever write this?
Waste of time.
It is a waste of time. You know why it's a waste of time? Because this is equivalent to what number? 0. I never write this either. Because this is a waste of time. What do you suppose dx over dx would be? 1. Okay, now I'm going to do one more thing. Let's say I have y equals x squared plus 6. And I want to figure out, I'm going to take the derivative with respect to another variable. And my variable is going to be time, or what I call t. We're going to be doing this next week. So I'm going to take the derivative of this variable. This variable changes, correct? That's why it's called a variable. So if it changes, there must be a rate over time that it changes. Allie, in no way do I want to embarrass you, but what I've noticed about when I am fascinated by hair. Okay, obviously, when I finally retire, I am going to open up a kiosk at the mall and sell hair accessories. I think it would be a hoot because I would have a picture of myself like this selling hair accessories. I think the contrast would be humorous. But what I've noticed, so I get fascinated by hair, that over a period of time, the color in your hair starts to fade. Would you agree with that? Okay, so there's a variable that's changing with respect to time. Does that make sense? So when I change this variable with respect to time, notice I say with respect to time, that variable t goes on the bottom. This will be dy dt. This will be 2x dx dt. What's so funny? Nothing? Okay. What? Oh, that's not funny at all. This is going to be 0 dt, because 6 never changes, does it? Because it's a constant. So I could take the derivative with respect. Denise, give me a variable. C. So I could call this dy dc with respect to c. dy dc equals 2x dx dc. And then I'd still get 0 dc because it's a constant. And so when I say respect to c or respect to time, I'm introducing a third variable. Does that make sense? I could take the derivative of this with respect to y. And then on this side, I would have dy over dy. I'd have 2x times dx over dy. And I would have 0 over dy. Does that make sense? Why is it 0? Because a constant never changes. Are we doing okay with that? Alrighty. So if we look at it in terms of the chain rule, here's y. That's really y with parentheses around the first. Over here I can have x to the second power plus 6. And if I use the chain rule, this would be 1 times y to the 0. I would come in here and change, multiply that variable by dy dx, because that's the rate at which y is changing. This would be 2 x to the first. The derivative of this would be dx over dx, which is 1. So I can look at it in terms of the chain rule. Plus 0 right there. So what is this going to look like? I'm going to leave all of these explicitly. Excuse me, I'll back up. I'm going to leave all of these implicit. So I'm going to have 2 times dx over dx plus 3 times dy over dx equals 0. That's going to become 2 times 1 plus 3 over dy dx equals 0. dy dx is going to be a negative 2 divided by 3. This is going to be dy over dx minus 2x dx over dx equals 0. This means I'm going to have dy over dx is equal to 2x times 1. Does everybody know where the 1 came from? Ty, do you know where the 1 came from? Every time that dx over dx is 1. And we will finish this up tomorrow.